So I'm recording this recording purely for extra example problems in case you guys were still a little bit confused. I do want to start with finding an angle in a right triangle. So here, anytime we're dealing with angles and sides of right triangles, we can apply trig to find missing parts of those right triangles. First step, always label your triangle. So here, theta is already labeled for us. That's what we're trying to solve for. Our opposite side is going to be that 5, and our hypotenuse is the 21. So we're not dealing with the adjacent side at all. We're just dealing with O and H. And if we remember from SOHCAHTOA, when we're dealing with O and H, that's sine. So this is a sine problem. Sine of theta is the second letter over the third letter over H. We're trying to solve for theta, and our opposite side is 5. Our hypotenuse is 21. Now, in the previous recording, I explained what happens here. In order to get the theta by itself, what you're doing is you're removing the sign. You're trying to divide by sign, technically. However, we don't normally see this. We don't normally see divide by sign. Instead, another way to think of this problem, or another way to think of dividing by sign, if I'm ever trying to divide by a variable, another way to write that I'm dividing by a variable, so if I was dividing by x, another way to write this with the x not in the denominator is by putting a -1 on the x. Technically, this is the, you would say, inverse of x. So here, instead of saying divide by sign, I am instead going to multiply by the inverse sign, which is the same thing as dividing by sign. So because I'm taking sign and dividing by sign, these cancel. And then my theta is equal to sine -1 of 5 over 21. So then I just take out my calculator and I do inverse of sine. You get the inverse by pressing second sine, 5 divided by 21. And you get 13.77. So that's what theta is equal to, is 13.77. And it's an angle, so we put degree. And I'm done. The next portion of problems is having us find all of the missing parts on a right triangle. So previously we were just finding a single missing part. Now we're finding all the parts, including the angles and the missing sides. So on this problem, again, I start off by labeling. I'm still going to start off the exact same way. 72 degrees is my theta. 15 is the side next to the 72, so that's my adjacent. My O is across from theta, that's my bottom, and my H is the hypotenuse across from the right angle. Let me fix that. So clearly we can see, okay, we're missing angle B. It does ask for angle B. We're missing the H side, AB, and we're also missing the O side. It does not matter which one we solve for first. I think that I am going to solve for O. Again, it doesn't matter whether you solve for O or H first or B. I'm just going to start by finding that CB length or BC length. So here on this problem, because I have 15 as my A and I'm solving for the O side, O and A makes this a tangent problem. So tan of theta, TOA, O over A. And I fill in my values. 72 is the theta, O is what I'm solving for, and A is 15. And to get rid of the 15 as the denominator, we're just multiplying both sides by 15. And you could also know that we'll be multiplying here because x is in the numerator. Anytime x is in the numerator, you're just multiplying the function times the denominator there, 15. So x is going to be 15 times tan of 72. We're multiplying both sides by 15 to get x by itself. We pull out our calculator and we do whole number times the trig function, making sure, once again, that our calculator is in degree mode, which it is. So our x length is 46.17. Which we just found that was our BC length here, 46.17. So now we can find the other missing parts. Now either you can use trig again to solve for h, or we now have two sides on a right triangle, you can also use Pythagorean theorem. Ooh, that doesn't work. So here, I'm going to, let's see, use red, no, we'll use blue. So I'm going to do the Pythagorean theorem. So I'm trying to solve for that h. So anytime I'm trying to solve for the c value, the h value, it's just the square root of your two sides squared added together. So that means I am going to do the square root of, now because this was already a decimal, I don't need to worry about leaving this in simplest radical form because it's impossible to do so with inputting a decimal in. Whoops, that should have been, no, 7. Okay, squared. So putting this in our calculator, the square root of 15 squared plus 46.17 squared, 48.55. So that length there was AB. 48 point, what did I say? 48.55. And then lastly, angle B. The only way to solve for angle B, you could use trig and find a missing angle, but there's an easier way. Instead, what you do is you know that a triangle always adds up to 180 degrees. So here I have angle A is 72, angle C is 90. To find the measure of angle B, you just do 180 minus the other two angles. And you get 180 minus 90 minus 72, 18. So the measure angle B is 18 degrees. And you're done.